Hi, I'm Jason Riggs.
And I'm Kevin Lamb.
And today we're here talking about mechanical seals. And specifically, Kevin, I want to address some questions that we typically hear from our customers, some FAQs, if you will, specifically to mechanical seals. So, first off, temperature limits. Talk to me a little bit about what the theoretical, kind of low and high temperature limits are for our mechanical seals.
Yeah, so when it comes to temperature, you're really limited by the materials you're choosing. Typical seals are going to use some sort of carbon element. Carbon's going to be good up to around 800 degrees Fahrenheit. There's also secondary seals in a typical contacting face seal where you're going to be using a spring energized PTFE or an elastomeric O-ring. Obviously there's a number of compounds that we can use, but you're probably still looking at around 300 to 500 degrees limits for a lot of those materials.
Okay, great. So another question we're often asked is, how fast can you go, right? And I think a lot of our customers are often thinking just about RPM. Maybe talk to me a little bit about how we think about speed.
So really it's more about surface speed than actual, rotational speed. And that surface speed, it's absolutely critical when you're trying to determine what your pressure velocity or PV is in the system. The more surface speed you have, the more heat generation, and then diameter also plays a big role into that. So you get a large diameter seal, you're going to have much bigger challenges when it comes to friction and surface speed.
Okay, so you mentioned that we don't necessarily worry about RPM per se. I think you touched on PV. PV is actually really the thing that we care the most about, and as you mentioned, the V being the velocity, that really what we're looking at there is the surface speed, which is a function of both the rotational speed and the diameter, but also the P being the differential pressure across the seal. And so together, that PV value, which is measured in PSI, feet per minute, has a theoretical limit for us, right? And we typically talk about something around 1 million PV as kind of being the limit. The reality is it's a little bit more nuanced than that, isn't it?
Sure.
Right?
Yeah, absolutely.
So if we start seeing PVs up around 1 million, we're really going to ask a lot of questions about that application, because as the PV goes up, life is certainly going to go down. And we might see 1 million PV in something like a turbo pump application and be comfortable with that. But if we're looking at a gearbox application, we may want to see a PV down around 250,000. So there's no hard, fast limit there, but it is a good way for us to have some initial dialogue with our customer about the application and some of maybe our concerns about pressures that are too high or surface speeds that are too high.
Right, yeah, PV really is the critical component when we're working through a design. I mean, it's really the factor that you have to consider when you're looking at heat generation, which in turn creates seal wear, and seal life is affected. So if you have a really high PV, your seal life is going to be much lower than in a lower PV application.
So the other thing that we're asked about a lot is size. How big can you go? How small can you go? What are your size limitations? What can you tell me about that?
So when it comes to size, I mean, really, we can customize the seals to whatever shaft diameter that we're trying to seal around. We can go down to 3/8 of an inch in diameter up to 10 inch in diameter. The more critical thing that we have to look at is the amount of space available, so the envelope, so to speak, that the customer's having us design around. We hear a lot of times that typical mechanical seal is not able to fit in really small envelopes, where we don't feel like that's the case. And a lot of times we can fit in even smaller envelopes than a lot of our competitors' products with the traditional mechanical seal.
So when we think about space, there's axial space, and we can actually make a very skinny, thin mechanical seal.
Yes.
And again, there's often a misnomer that our standard mechanical seal types don't fit. We custom engineer to fit in very small axial spaces. And then radially, again, we're thinking about PV more than we're thinking about physical size limitations, right?
Yeah, exactly.
Okay. So another question that we get often is, what are we capable of in terms of leakage with mechanical seals?
Essentially every seal leaks. There's not a zero leak seal out there. When you start talking about a face seal, you really need to think about the pressure differential, because that's essentially what's going to control how much leakage you're seeing. In a face seal, you're talking about something drops per minute, some very small amount of leakage to no visible or measurable leakage. You start talking about a circumferential seal, you're thinking more of a controlled leakage where you could be up to gallons per minute. The whole system is designed around being able to accommodate for that leakage.
So the last question I wanted to ask you about is material. We work in a variety of different environments, both in terms of the fluids that we're sealing, the media that we're sealing, temperatures, et cetera. Talk to me a little bit about I guess, the materials that we have at our disposal to work in these different types of critical sealing applications?
These seals are highly customizable, so you really have to take the application conditions that you're given and customize the seal accordingly. So the different seal components require different materials. I mean, we use carbons and ceramics in most cases for the sealing element because they provide some lubricity, which is important for the sealing element. The housing and the springs and bellows, so to speak. I mean, we're using a lot of high performance alloys and stainless steels. When we start talking about secondary seals in these applications, it's usually like a PTFE spring energized seal or some type of performance elastomers. There's tons of stuff out there, and you're really looking at the temperatures in the application and the fluid that it's exposed to, and you can really choose whatever polymeric component that's going to meet those requirements.
Well, I appreciate you running through some of those FAQs. Hopefully that helps address some of the common questions that were asked, and we appreciate everybody for watching.